For the rest of Unit 3, we're going to look at quadratic functions and the properties that they have and the different types of equations we can write for a quadratic function. The definition of a quadratic function, and basically this is an equation, it's written in standard form. And we have y equals ax squared plus bx plus c. And we also designate that a cannot equal 0. Because if a were to equal 0, that means that this first term is going to equal 0, and we're left with bx plus c. And we know that from the last unit that this is a linear equation and it would not make it quadratic. And the graph of a quadratic function is a parabola, and we've looked at the graph of the parent function, which is y equals x squared, and we have a parabola with the vertex centered at the origin. So here it asks us to graph the parent function, and down here it's asking us to graph the parent function where it's multiplied by a constant and that constant is greater than 0. So if our a value, meaning a is greater than 0, is positive, we know that if I were to multiply it by a number that's bigger than 1, I would have some kind of compression in my parabola. So I could say that this is y equals 2x squared, for example. And when that a value is bigger than 1, then we get a parabola that gets skinnier because it's going up twice as fast. If we multiply by a fraction, and keeping in mind that if it's a positive fraction, then this is going to be a number between 0 and 1. So we could say that this is perhaps y equals 1/2 x squared, where the parabola actually gets fatter or wider because of the 1/2. If the parabola had an a value that is less than 0, so a is negative. Maybe I want to say over here that a is positive. If a is negative, our parabola is going to be reflected across the x-axis, so it's going to be pointing downward. The same thing has to do with the value of a. So this is the equation y equals x squared, where here a is 1 times x squared. And if I multiply my a by 2, it's going to get skinnier as it points downward. So I can say that this is y equals negative 2x squared. And also, if I were to make my a between -1 and 0, meaning it would be a fraction, I could say that this is y equals like -1/2 x squared. And the same thing happens as it happened over here. It's getting wider, and the negative indicates that it's going to point down. A couple other pieces of vocabulary here, and a parabola will have what's called an axis of symmetry. So this is a vertical line that goes through the vertex. Okay, so the vertex we know is the point where the parabola changes direction, and we have in the past used the value of h and k to represent the values of the vertex, where h would be the x-coordinate of that vertex and k would be the y-coordinate. If I were to want to find the coordinates of the vertex by looking at the standard form of the equation, I could use a simple formula, and you're going to need to really know this, where the x coordinate can be found by the opposite of the b value divided by 2a. This would give us the x coordinate, and the y coordinate would be the value of the function when I find the x coordinate minus b over 2a. So really what I'm doing here, after I find the x coordinate, I'm plugging that value in for x to find y. Okay, so this is my x coordinate, this is my y coordinate. So if I do an example of just finding the vertex here, I'm going to identify, first of all, I have my coefficients a, b, and c, and I'm going to identify that a is 2, that b is 8, and that c is 5. And then to find the x coordinate of that vertex, I'm going to find the h value, and I'm going to use minus b over 2a. And I'm going to plug in the values for b and a here. So I have the opposite of 8, minus 8, over 2 times the value of a, which is 2. This would be negative 8 over 2. I'm sorry, negative 8 over 4, which is negative 2. So in my vertex, I know the x coordinate is going to be negative 2. The y coordinate, or the k value, is going to come from taking negative 2 and plugging it back into the function. So I would have, if I rewrite my values with x being negative 2, 2 times negative 2 squared, plus 8 times negative 2 plus 5. And if I simplify this, this becomes positive 4 times 2 is 8, minus 16 plus 5, which is negative 3. And the x coordinate of the vertex would be negative 3. So if I were to just graph this here, just a little quick graph, I know that my vertex is going to be negative 2, negative 3, and I know that it's going to point up and be pretty skinny because it's going to have an a value of 2. It's positive, so it's pointing up. And I also can tell that from this equation, my y-intercept is 5, and that's because if I plug in zeros for x, this is 0, this is 0, this is 5. So y would equal 5. Okay, so if I put 5 on my y-intercept, I can pretty much draw my graph here. I know my vertex, to 5 on the y-axis. And because of my axis of symmetry, I know that this point is going to be reflected the same distance. So if this is at the point negative 2, and I take this point and move it 2 units to get to the axis of symmetry, the reflective point is also going to be 2 units, and I can draw that side of the parabola. All right, so looking at the next page, this is just kind of a summary of what we have done already. We're looking at the function ax squared plus bx plus c. We have the vertex, and we know that the axis of symmetry is the line x equals minus b over 2a. And keep in mind that the axis of symmetry is a vertical line, and we've written the vertical line as equations before, and the equation of a vertical line is x equals some constant. Okay, and that constant will come from minus b over 2a. So on number 2, it says without graphing, locate the vertex, no graphing here, locate the vertex and axis of symmetry of the parabola defined by this function. Okay, so does it open up or down? Well, I can answer that quickly because I see that my a value is negative, so I know it's going to open down. Okay, answer that right off the bat. So if I find the x-coordinate of the vertex, and I'm just going to write this, a is negative. To find the x-coordinate of the vertex, which would be the h value, I have x equals minus b over 2a. So if I define my coefficients here, a is negative 3, b is 6, and c is 1. I'm going to put those values into this formula here. So the opposite of the b term, the opposite of 6 is negative 6 over 2 times negative 3. So this is negative 6 over negative 6, and the x-coordinate of my vertex is going to be 1. So I'm going to write that my vertex is here, my x-coordinate is 1. To find the k value, which is the y-coordinate of my vertex, I'm going to take 1 for x and plug it back into the function and rewrite that. So I have minus 3 times negative 1 squared plus 6 times, oops, that's positive 1, sorry, plus 6 times 1 here, and then plus 1. So this is negative 1 squared is 1 times negative 3 is negative 3. This is plus 6 and then plus 1, which is 4. So the y-coordinate of my vertex is 4. And it also asks us to identify the axis of symmetry. So I call that the AOS. And the axis of symmetry is the equation x equals something, and it is the same as the x-coordinate of the vertex. So that is x equals 1. And I think we're going to stop here and do some practice, and we'll finish up on another day.